Good morning, guys. And today our topic is radiation pyrometer, and then we will go for the optical pyrometer. So, say in case there is some furnace, okay. If there is a furnace, say this is our ladle furnace. This is our ladle furnace. You can say this is the arc furnace. In this ladle, there is some arc furnace is also there. So these are the flame, or in any type of furnace. Okay, or any type of furnace, we need to measure some temperature, because if say this is scraps materials are there, we need to melt it. But to melt these irons or melt this metal, we need some specific temperature and for the specific time. Without this time and the specific temperature is not reached, then this metal will not melt properly. Okay, so and it is not getting good mold, and that's why we need it good temperature. And not only good, actually flow of temperature required very nicely, and it should be maintained at a particular time. If the temperature is very high, then what happens? Then ladle itself became melt, okay, or anything maybe damaged, okay. But we need some specific temperature for specific metal melting. So that's why we need to measure this type of temperature. But so here we need to measure this temperature. But how could we measure this temperature? Look, TC is generally 700 degrees. This is not negative. This is generally this type of temperature is withstand, but we need this melting temperature in your furnace maybe above 203. This type of temperature is there, or more than this. And not only that, it this this temperature measured for the TC. But remember, uh, this alkyl material, this material this covering material, it is made of alkyl. This is not permit this type of temperature. Okay, this is not permitting. Yes, yes, anyone? It is not permitting this type of temperature. PC permit this temperature, but this covering material not permitting, it became melt. So how could I measure this? So in prior to coming of this pyrometer, generally what happens in this area, there is a big type of TC. And here I want to explain share this experience. Then you can understand what are the actual phenomenon happens in the industry, and very difficult thing. So this is a platform. This is a big platform, and here is a human being. Okay, here is a human being is there, and you can understand what are the figure ratio, what are the height, and what are the capacity. Look, this is a big arc furnace. This is called arc furnace, and this is very much advanced melting process of arc furnace. Generally, ores are not melting over here. The scraps material. Maybe this is the railway broken again wheel. This type of things are there, and this is coming. So this technology was adopted from Japan, but this technology was 50 years old for this Japanese technology. But when technology became old, then this country sell this technology. Okay, but for India, this technology is called advanced melting technology, because ores are directly not melt. Rather, this scraps material means this is already a iron and the steel material or anything, it will directly melt over there. Okay, so the profit is very high, because if we spend 5 rupees, look, economy, this is the economy. Okay, if we spend this 5 rupees per kg, and then we get just like uh, just like 100 rupees per kg, and this metal, when there is the output and when there is a input for kg, and there is some cost is there for other cost, but this is the thing, so profit is high. And this is moreover, this is the recycling process. And now this is the economy, and we have to, being an engineer, we have to always remember the economy. If you don't go for economy and don't go for quality, then your production and will not acceptable to the global market, or not only the global market, this is not for the uh, Indian market also. And now look this, uh, this phenomenon, human height is just like 5 feet, and this is almost 25 feet its height. So, and temperature is around uh, 118 degree centigrade, 108, sorry, 1800 degree centigrade. This much of centigrade, this to this. So how this is possible? We can measure this RTD or thermocouple. Thermocouple can measure this, but the casing of this thermocouple is not allowed this type of temperature. So here a human is just waiting there, and from this platform, this is the high platform. Maybe this is above 20 feet. Okay, this 20 feet height, it is emerge a RTD, it is emerge a RTD or the TC as per requirement, but this TC is withstand only for 5 seconds. This TC withstand only for 5 seconds. Within this portion became melt. Within this 5 seconds, it will take the reading. Yes, this temperature is there. So if we required 6 times taking a reading, so 6 TC became damaged. So there is a R&D section, not only R&D section, maintenance section. There one person is always uh, uh, always building a this type of TC. Okay, and they always one by one they are making this TC, because every day, every shift, they use 6 TC, because this tip portion became just damaged. Again it is here, and this is the open, and this type of casing is not there. Just like one iridium, rhodium, iron, ferrum, K type, J type, this type of RTD, here is the handle, direct emerge, direct it is coming to the contact. So this is very difficult task. So nowadays it is the real phenomenon of the industry. Nowadays the real the this difficult task is removed by the optical pyrometer. Optical pyrometer is the non-conductive temperature detector. Okay, and it can detect the temperature. Now we are going for the uh, next topic. Yes. So our topic is pyrometer. There is two type of pyrometer. One pyrometer is optical type pyrometer, and second is radiation type. ठीक है. So this is two types of pyrometer. One is optical and second one is radiation pyrometer. I want to explain the phenomenon what happens there. Look, this is a furnace. This is a furnace. So there is some flame is there, and the temperature is around 100 1060 degrees 600 centigrade to 100 1806 centigrade, means this is 1600 degrees centigrade to 100 1800 degrees centigrade. This much amount of temperature and maybe more than this. Okay, in this furnace, because ores are melting or the crabs material are going to melt. So what happens, this type of temperature is not it is not possible to measure by human contact or any contact type instrument, and though it was measured, but it was very difficult. All time your sensor will be damaged and it will withstand for 5 seconds. So what happens, here we are getting some optical pyrometer. Optical pyrometer means we are just measuring the temperature by watching the color of flame. This is the main logic of this pyrometer. Say this is the flame. You know, whenever a blacksmith mill just doing its work, some iron pieces are getting heated and then it radiates some color. Say this is the red color. First, when it was heated, then it became very heated, then it became red color. Okay, then if you make this temperature arise, then it will become just orange type color. If you heat more, then it became yellowish color. And if you heat more, then it became totally whitish color. So as per this color, you can see this is big flame color became different. So first it is getting red color, nor then it is became orange color, then it is became yellowish color or yellow color. It is not. Then it became white color. Then it became white. So if we can measure, if red is around 1000 degrees centigrade, then we can watching this color we can compare this. If above this, then this is orange. This is the pyrometric operation. So what happens in this furnace? There is a glass window. Okay, there is a glass window, but this is not a proper normal glass, because if normal in practice whatever you have seen this glass, because this glass will not withstand this type of temperature. These glass are hydrogen enamel. These glass are hydrogen enamel. Liquid hydrogen are enameled over this glass. So so this is hydrogen enameled. Okay. So what happens? A light beam is coming from this glass window. This is a light beam is coming from this glass window. And there is our pyrometer. Pyrometer is look like this. This is lens. So the light beam are coming. So light beam are coming here. And here anyway, but this is all are parallel. Light beam are coming here. This is the eyepiece. Okay, this is not lens. Sometimes it may be a lens, sometimes it is not lens. It is as per requirement, but this is must be a lens. So this lens just creating this light in a parallel lens. Here there is a filament bulb. Here there is a filament bulb is there. Here is a filament bulb is there. Okay. Here is the power. Uh, Here we can measure this current, and there is some power also there. Look, this is the construction of the radiation pyrometer. Sorry, this is the construction of optical pyrometer. First one is optical pyrometer. Because we are watching this, that's why this is the optical pyrometer. Look what happens if we are increasing the intensity by this resistance. We are increasing the light intensity by this resistance, or we are decreasing the intensity of this light by this resistance. Okay, so what happens if this surrounding light, this is the surrounding light, and this is the light from the filament. This is the light from the filament. This is the light from the filament, and this is the surrounding light. Look, if the filament light is much brighter, if the filament light or the filament is looking much brighter, this is the bright filament, you can see. And surrounding area is uh, quite darkish. Surrounding area is quite darkish. Filament is bright, and in this case, second case, there is filament. Color of this filament is quite dull, and the surrounding area is bright. Surrounding area is bright. And next case, the filament is not observable, means there is, you can't see no filament. So what happens? This is filament is bright, surrounding area bright, and no filament. No filament. What happens? Because when filament is bright and surrounding area is dark, means the the intensity of the filament is much higher than the surrounding light. Surrounding light means light coming from the furnace, and it is watching from the pyrometer. And the second case, surrounding area is bright but filament is dark, means the intensity of this filament is much less than the surrounding area of this light. But we have to set this filament intensity so that filament became vanish, means the total light surrounding it, light of the surrounding area and light from this filament and is totally same, then the filament will be not visible. This type this temperature and this light is observable, and then from this measuring instrument detect this position. So this is the working principle of pyrometer. So if we know, uh, say this is the current is uh, at the time current is 0.5 ampere. So if 1 ampere, 0.1 ampere is current is flowing, then it is dark, or it may be one, it is 1000 degrees centigrade. If zero point 0.2 ampere is flowing, then this is 100, 1200 degrees centigrade. If 3, then 100. So if we make this scale, we calibrate this light intensity with this current, flowing of this current through this filament, then we can easily measure the temperature of this furnace. So in this way, we can measure at the temperature of this furnace by using this optical pyrometer. But you can see the accuracy of the optical pyrometer is very less, because it is the temperature rising is rapidly changing, and so in between the 1000 degree to 1200 degree there is no measurement position is there. So like the thermocouple or RTD or any thermistor, we can measure 1 degree change or 5 degrees change, it is observable. But in this case, more than 100 degree to 50 degree centigrade is not measurable. Okay, so this is called the resolution, because the smallest division could be detected. So here the resolution is very less, but in case of our RTD, thermocouple and the thermistor, the resolution is very high. But we can go for the higher range of this temperature. So in optical pyrometer, generally it is measure 100, sorry, 2100 degree centigrade, and the radiation type pyrometer can measure 2300 degree centigrade, in this range. Now we are coming to the radiation type temperature detector. Look here, again we are going for the hydrogen enameled window. From this window, oh, light beam is coming. From this window, light beam is coming. Here, first, in a pyrometer, there is a lens. There is a lens, but this type of lens, we have to set a focus on a particular area. We have to select this so that it is focusing particular in a focal point. Now, in this area, a thermocouple or a RTD, or it may be any temperature detector like thermistor, we can put over here. So We generally use TC because TC directly giving the measuring signal. So in this way, there is no optical portion is there. Okay, and here is some mirror also there. So from this mirror also some beams are coming over here. So in this case, you can see the flame is there. Flame is there. From this flame, light is coming from this hydrogen element window, and this window here it is coming to the lens. This lens just just converting the all beams of the light into a focal point. Then this focal point easily became heated. This temperature is measured by this thermocouple. So whatever the thermocouple is measuring, it is due to coming from the furnace. So if we can calibrate, or if we can make a scale, say their thermocouple is showing some voltage, because thermocouple giving the output in the sense of voltage, in the in by means of voltage. Okay, and this voltage is range of millivolt, generally uh, uh, up to the point 5, sorry, up to the 5 millivolt it is producing. So this is the millivolt range. So if 1 millivolt is 1000 degree centigrade, 0.2 millivolt, sorry, not 2 point, this is a millivolt. If you use millivolt, then don't use point decimal. If you use volt, then you use decimal. Okay, so if 2 millivolt, we are using millivolt directly, so no need of decimal signal. So 2 millivolt, say 1200 degree centigrade, say 3 millivolt, that is 1400 degree centigrade. If there is a 4 millivolt, say there is a, say there is a, so each millivolt giving 200 degree is centigrade. So in this way, if we make a scale, then we can easily measure the temperature of this furnace. This is called the calibration. Okay, and the smallest difference between these two measurements, this is called the resolution. And in this way, we can measure this type of pyrometer. And guys, if you have any question, you may ask me. So the range is 2300 degrees centigrade. So industrial purpose uses generally the furnace. Specifically, furnace temperature going to rise this type of temperature, and there we need this type of pyrometer. So this is the non-contact type. This is called non-contact type temperature detector. Okay, and another temperature detector, that is contact type, that is called RTD. So if you have any question from pyrometer, you may ask me. Otherwise, I am going to the next. And next, this is RTD. RTD stands for resistance temperature detector. Okay, RTD stands for resistance temperature detector. So this is normally a resistance. Generally, this type of resistance is made of platinum. That's why it is called PT100. Okay, a common RTD is PT100. So this is a resistance. This is a resistance. So if there is a temperature arise, if there is a temperature, then value of this resistance will vary. If temperature is vary, then resistance also vary. So there is a proportionality relation. So if we can measure the resistance, then we can also measure the, by virtue of this proportionality, we can also measure the temperature. This is the fundamental logic of the RTD. Now, RTD is generally made of platinum wire. or it may be anywhere, just like made of ferrum, copper for the higher range, but common RTD is PT100. Sorry, not degree signs. Okay,
सर
so
दास
yes,
सर मैसेज किए थे सर.
okay. So I am stopping here. Thank you.
थैंक यू सर.